All right, so now let's see an example of how to do this. And so here's the example. And each week, Lloyd's department store selects a simple random sample. I'm just highlighting some terminology here. And we learned about simple random samples. And so if we wanted to randomly select, customers, how would we do that? How do we randomly do that? And if we had a roster, if it was finite, we could say, okay, we're going to give them all a random number, then choose the 100 smallest random numbers or the 100 largest random numbers. Or if it's a infinite, meaning customers just keep coming in, a simple random sample might be we select every other customer. So when a customer uses coupon, we select the customer that comes after the person who used the coupon, and we just do that 100 times until we've selected 100 customers. That's pretty random. So each week, department store selects a simple random sample of 100 customers in order to learn about the amount spent per shopping trip. The historical data indicates that the population follows a normal distribution. During a most recent week, Lloyd surveyed 100 customers, so our sample size is 100, and obtained a sample mean of X bar equals 82. Based on historical data, Lloyd's now assumes a known level, a known value of the standard deviation of the population is $20. The confidence coefficient, aka confidence level, to be used in the interval estimate is 95. So our alpha would be 0.05, right? And alpha is also known as our level of significance, right? So our alpha would be 0.05, which is also the level of significance. And the confidence coefficient is also known as the confidence level, is 0.095. So alpha, aka I don't even know, right? Like I gotta look it up. These terms are still new to me. Level of significance, that's right. So alpha, aka level of significance is 0.05. There we go. All right, so let's calculate this. And to do that, I'm just going to insert a new slide here like that. And I'll take this one out, pow, and I'll add this one, copy it, and then just paste it in here like that. And I think I'll make each of these with like smaller text. So we'll just do like 14, and that's pretty good. And I don't know if I'll need this over here or not, but oh yeah, that's just there until you click on it. So we know what? What do we know? I'm going to copy this and launch a new one, and then bring this out on its own and bring it over to the right, and then bring this one over here and bring that one there. And now I can look at this one. So we know that n is equal to 100, and I think I'll make this bigger because that's pretty small when we're looking at it at this level. That's all right. I need a little room to work. And so, and then what do we have? Sample mean. So sample mean, I don't know how to do the X bar thing, is 82. And then what else do we know? And the population stand. I could just, is that text? I'll do this. Population standard deviation is equal to 20, right? And so we want to know 95% confidence. So confidence level is going to be 95%. I like percentage over just 0.95. And our alpha, right, which is our level of significance, is 0.05. So knowing those things, we want to develop with 95% confidence, right? We want to be able to say, hey, based upon our sample mean, 82, plus or minus some amount is going to include the population mean. So that's what we want to figure out. And to figure that out, we use this formula here. So we have x, and we could just copy this here maybe and bring it over. So I'll bring this one down, and we'll put that here. So there's the formula we're going to use. And we have x plus or minus z alpha 2. So at 95% confidence level, here's 95%, we're going to have 5% distributed between these two tails. So alpha over 2, because these two tails are our alpha, and our alpha is, what is it called? Our alpha is our level of significance, right? And, our alpha will be between these two tails, the level of significance. And alpha divided by 2 will have, if this is 5%, because this is 95%, 5% is between these two tails, then 2.5% here and 2.5% there, which is why this is like described as alpha over 2 here or alpha over 2 here, or z subscript alpha over 2. So we've got 2.5%, right? 2.5%, which means that this is at 2.5% right here, so 2.5% of our data is here, which means that 97.5% of our data is there to the left. Well, if we go to our z-score and look for 97.5% of our data to the left, we're looking for 97.5. It's right here, so we want 1.96. So our z is going to be 1.96, and we'll put that here, and we'll put z is equal to 1.96. And if I could do a little subscript alpha, I'd do that. And I'm going to make this a little bit bigger too. We'll make this 18, and that's a little bit better. And so we have our alpha, and then we need to know our population standard deviation is 20. So 20 divided by the square root, and I'll do SQR2, square root of our sample size, which is 100, right? That is going to be equal to, so square root of 100 is 10, because 10 times 10 is 100. And, square root is basically undoing the square. And if you want to check that, you can launch a calculator. I do want to check it. And you can type in 100, and you could do square root. And I'm not seeing it, so I'm going to just make this bigger. And square root right there. Boom. And that's 10. So there we go. So it's going to be 20 divided by 10. That's equal to 20 divided by 10. And that's going to be equal to 2. And so to calculate all of that, we're going to have 1.96 times 2. And 1.96 times 2 is going to be equal to 2. Because we do this z stuff, 1.96 standard deviations. And then we multiply it by this, right, which is kind of the number of standard deviations, but somehow, for whatever reason, you divide it by square root of n. And when we multiply that, 1.96 times 2, we get 3.92. 3.92. So and to kind of get this terminology here, I'm just going to bring this up so maybe we could reference it. There it is. With 95% confidence, the population parameter of the population mean will fall within the confidence interval, which is also the interval estimate, right? AKA the interval estimate, of the point estimator, the sample mean point estimator of, that's going to be, the sample mean is 82, and it's going to be plus or minus the margin of error, which is 3.92, so that our confidence interval, aka interval estimate, is 82 plus or minus 3.92, or this. So it's going to be 85.92, and we'll do little arrows here. We'll do boop, 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 and it'll be between that, and I need to type in 82 minus 3.92, 82 minus 3.92, and that's 78.08. So we'll come here and we'll enter. I'm just going to close all this actually. 78.08. I'm going to make this big. And 78.08, 78.08, 78.08, 78.08, 78. Where's the slide I'm working on, man? 78. Just 1 second. I got to find the slide I'm working on. Here we go. 78.08. 78.08. So that is our confidence interval or interval estimate. And with 95% confidence, and so I'm just going to highlight some of these phrases. 95% confidence, the population parameter, is that how you spell it, or is it like this, parameter, of the population mean will fall within the confidence interval, aka the interval estimate. The confidence interval, aka the interval estimate, right? And this, by the way, is the confidence interval estimate of the sample mean point estimator of 82, right? So sample mean point estimator, plus or minus the margin of error, right? So let's learn the terminology, which is 3.92, so that our confidence interval, aka interval estimate, is 82 plus or minus 3.92, or this, right? So 95% of the time, based upon our sample mean being 82, with 95% confidence, and 95% confidence is our confidence level or confidence coefficient, and our alpha level of significance is 0.05, right? So 95% of the time, the population parameter, the mean, population mean, will fall within this range based upon our sample. And so if we look at how the book did this, 95% of the sample means that can be observed are within plus or minus 1.96 standard error, right? And of the population mean, the margin of error is, and so this is margin of error, and let's just make sure interval estimate of mu, and it'd be nice if this actually said, interval estimate of mu is the, and I'm just going to stretch this out, is the sample mean plus or minus the margin of error. And we'll make this smaller. Boom. I don't really think the textbook does the best job of explaining some of the stuff, like you're seeing how the slides could be clarified. And I'm going to copy this and just bring it down and put that here. And I need to shorten it. And we'll take some of the text out. The margin of error. And we'll just do it like that. And we'll make it like this. Margin of error. And then we'll bring this here. And I'm going to make it even smaller. We'll make it like 12. And bring that in like that. Bring this over. And then we'll draw an arrow to this stuff here. And this is the margin of error, this stuff, okay? So all that stuff is the margin of error, not this, right? That's the sample mean. But the plus or minus part is the margin of error. And it'd be nice if I had like a little curly Q. I wonder if I could do a curly Q. So I'm looking for the curly Q, curved connector. Maybe this would work. I could go like this. And can I move that? That doesn't work. Let me pause this and see if I can find it. I just saw a new one here that I haven't played with before. So it's right here and it's scribble. And let me just see if I do scribble. That works for me. It's good enough for government work, right? So that's our margin of error, all of that stuff. All right, so we did that calculation, and there was our calculation, and we came up with the sample mean, right, is going to be plus or minus 1.96 the standard error. So 1.96 times 20 over 100, and we did 1.96 times 20 over the square root of 100. Same thing there, 1.96 times 20 over the square root of 100. Gave us 2 times 1.96, which is 3.92, and they got 3.92. And so the interval estimate of the population mean is 82 plus or minus 3.92, or 78.08 to 85.29. And we came up with 78.08 to 85.29, 85.29, 85. Ooh, I had a little bit of dyslexia. 85.29 right there. And so let me just check to make sure that, yeah, 85.29. Is that right, or are they wrong? What's 1.96 times 1.96 times 2 is 3.92, so they were wrong. So this is supposed to be 3.92, and they had a little bit of dyslexia. Okay, so textbook isn't always right, but that should be changed, and I can't change that text because it's an image. So we are 95% confident that the interval contains the population mean. That's statistics, ladies and gentlemen. So here we looked at the 95% confidence level on that one, right? Because we were looking at where's our sample? We wanted 95% confidence, right? So that's our confidence coefficient, our confidence level, and our alpha, or our level of significance, is 0.05. And I'll highlight those just so that they pop. Highlight and highlight, 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 highlight. And then here we have, this is what it looks like, different confidence levels. And here they got it right, you know, because the correct answer was 85.92, and here they have 85.92 at the 95% confidence level, 78.08 to 85.92. And maybe I fixed that because I can fix that, so that probably is me that fixed that. And then the 90% confidence level, you know, we have less confidence, so we have a more narrow interval estimate, right? It's not as wide as this. And this is the widest, which means we have even more confidence that our population mean will fall within this confidence interval, right? This interval, this confidence interval, this interval estimate. So, you know, the wider, which one am I looking for? I'm looking for, where is it? I'm looking for this one. The wider our margin of error, right, the higher our confidence. Because if I say a really wide margin of error, right, if the average height from my sample is 5 feet 8 inches of humans, and I say, right, like, I have 99% confidence that most humans are going to be between 1 foot and 10 feet. And that's true, because I have a really wide margin of error, you know, so it's going to be 5'8" plus or minus 4 feet, you know, and so the wider my margin of error, the wider my interval estimate, the more confidence I could have that, you know, this sample with the sample point estimate with its margin of error, creating the interval estimate, is going to contain the population parameter characteristic of interest, the population mean. So in order to have a higher degree of confidence, the margin of error, and thus the width of the confidence interval, must be larger. All right, last slide in all of this. Interval estimate of a population mean where the standard deviation of the population is known. Adequate sample size. Most applications, a sample size of n greater than 30 is adequate. So we're seeing that as a common theme. And if the population distribution is highly skewed or contains outliers, a sample size of 50 or more is recommended. If the population is not normally distributed but is roughly symmetric, a sample size as small as 15 will suffice. And if the population is believed to be at least approximately normal, a sample size of less than 15 can be used. All right, so that's creating an interval estimate of a population mean when the standard deviation, the population standard deviation, is known. And we'll do some more. See you in the next video.